no questions. Wilfred, why is that a painful intro? Well, back in the day, it was all we had. All right, so today we're going to be talking about data modeling, an introduction to data modeling. Data modeling is kind of at the base of building good databases. When you design a data model, it's important to make sure you're designing it correctly, and making sure you're getting all of the columns that you need, and making sure you're organizing everything, because a bad data model can really wreak havoc on a system. So really, like, what a data model is, when you get down to it, a data model, it's an abstraction of the information that a system needs to fulfill its purpose, right? So it's an abstract, it's like a chart basically of how your database is going to look. And it's something that you should always plan out before you actually create your database. So we're going to go over data modeling. We're going to go over some different ideas of data modeling, including things like table relationships. We've kind of done, I think you've kind of done some stuff with table relationships in previous lectures. As far as like relationships like one-to-many, one-to-one, many-to-many. So we're going to talk about that. We're going to talk about normalizing the data model. And then we're going to actually go through and we're going to create a real world example of a data model, kind of from the perspective of if you were to receive requirements from a client. We're going to whiteboard it out. We're going to actually draw a data model, and then at the end, we're going to go through and implement that using Next migrations. So hopefully that should give you a little bit more experience using Next, a little more experience creating migrations, creating seeds, and things like that. So let's get started. Let me just pull up my notes here. How did you guys feel overall with the previous guided lecture, the one that you were supposed to watch, the recorded lecture? Do you feel like that? Do you feel like that was pretty straightforward? Do you feel good about migrations, seeds? Wasn't too bad. That's good. Dustin couldn't keep your attention. Yeah, maybe it'll help to go through the project tonight. You know, we can actually go through it together, and hopefully it'll help keep your attention, help you learn a little bit more. Okay. Yeah, Michael, kind of once you get into it, it just, yeah, I mean, it seems confusing from an outside perspective when you're kind of looking at all of the different details, but once you actually get in there and start working on it, it makes a lot more sense. Ronnie, yeah. So tonight, a lot of the stuff that we're going to talk about is like theory. So probably the first half of this lecture is just going to be pretty boring. We're just going to talk about some theory. We're going to whiteboard some stuff out. It's important stuff to know. I know it can get boring, but it's important to know. So bear with me as we go through that. I'll try to keep it quick, you know, so we can kind of get on with the nitty-gritty and actually start creating stuff. Yeah, he did go on a massive tangent. I did watch some of the lecture, and some of that stuff was pretty confusing. So I'm going to try and go over some of the stuff that he went over and try and explain it more in detail. But please feel free to ask questions if, you know, something is confusing. It's a lot different to watch a YouTube video, you know, without access to the instructor versus tonight when you actually have access to the instructor and you can ask questions. And it's kind of like a live interactive session. So hopefully it'll keep your attention a little bit better. So I'm actually, we're going to do some whiteboarding, I'm just going to do it on my iPad. I can share my iPad screen and we can go from there. So let's talk about kind of what a data model is, and kind of like the wording, some of the nomenclature. So when when you're creating a data model, you're basically drawing out your database in terms of like the tables. You're drawing out tables, you're drawing out properties, you're drawing relationships between tables and properties. And so when you're drawing out a data model, there's a few words you should kind of be aware of. One of them is entities. So an entity in a data model is the table. So when you hear the word entity, that means the table. Another word you're going to hear is properties. When you hear the word properties, that's referring to columns. So you have entities and you have properties. It's the same as tables and columns, right? And then we have relationships. Relationships is the big one that we're going to be talking about tonight. Relationships are essentially how certain tables are related to each other. You know, you might have a users table, right? And the users might have followers. And so those two are related. Obviously, you can't keep the follower data in the user table. You have to have it in a separate table. And in order to do that, you have to have relationships. So those are kind of the three keys you need to know about: is entities, properties, and relationships. Draw.io. Yeah, Draw.io is pretty cool, Jasmine. Yeah, 2 video lectures in a row. It definitely helps if you can interact with the class and the TA and the TAs and your instructor. It definitely helps to get a better grasp on things. So hopefully this will help you out tonight. Good one, Dustin. Okay, so let's talk about relationships. Relationships in the context of databases. We could talk about relationships in the context of our lives, if that would be more interesting. But let's talk about it in the context of databases. So let me share my screen real quick, just so I can open up the training kit for you. Okay, so when we're talking about relationships in the context of a database, there are 3 different types of relationships you can have. So the first type we're going to talk about is a one-to-one relationship. Now, this is when you have 2 different tables that are related to each other in the sense of one row in the first table can only be related to one row in the second table, and vice versa. So you can kind of think about this in the context of, let's say, in the context of like a customer and a profile. So let's say we have a database that has a table of customers. And let's say our app also has, think about our app also having a social media aspect to it. So we have another table outside of the customers table, which is the profile table. And let's say in the profile table, we have columns like, I don't know, like profile picture, maybe like GitHub link, portfolio link, bio, things like that. This is stuff that's not necessarily important for the customer data, but it's important for the social media aspect, for the profile data, right? So you don't want to necessarily store that stuff in the customer table, right? So the customer table would have essentials to the customer, like it would have a name and a phone number and an email, things like that. So essentially you have these 2 different tables that relate to the same thing. They relate to the same entity, which is a person, you know, a customer. So the way that you would link those together is a one-to-one relationship. Keep the off-color, not suitable for work jokes out of this lecture. Come on. I'm kidding. I would be okay with it, but I'm sure the Land School of PR would not. So one-to-one relationships. So in the context of customers and profiles, they link together with what's called a foreign key. So let's say in the profile table, you would have a column that's called customer ID, and that links to the customers table, right? And the reason it's one-to-one is because the customer can only have one profile and the profile can only have one customer, right? So they can only be linked to one item each. So that's why it's called a one-to-one relationship. That being said, one-to-one relationships are not super common in the database world. It's pretty uncommon to actually code something like this. It's usually when you're dealing with a lot of data, when you're working on a really large system. But you won't necessarily see it a lot. So it's good to know about it, but don't expect to use it a lot. Any questions about one-to-one relationships? Thank you, Justin. You like the jacket? I've had it for like 4 years now. It's starting to get pretty worn out. One-to-many relationships. We're going to talk about that. So no questions on one-to-one relationships. So do you understand, actually, I'm not quite sure what you've reviewed so far in the previous lectures. So do you guys understand what a primary key and a foreign key is? Just put it in Slack, yes or no, if you understand what primary keys and foreign keys are. Okay, so you have covered that, awesome. Perfect. So in the context of a one-to-one relationship, which side would have the primary key and which would have the foreign key? Well, you have to understand it now. We're going to talk about it. You got to understand it for this lecture, so that's why we're talking about it. Justin is right. They might have both. It really depends on which entity is the main entity, right? The main entity will always have the primary key, and the secondary entity will always have the foreign key. The foreign key points back to the primary key of the primary entity. So that's a little bit confusing. I understand that's a little bit confusing with one-to-one relationships because it's not really clear which one is the primary entity and which one is the secondary. But this will make more sense when we talk about the next one. So next relationship, one-to-many relationships. So a one-to-many relationship is the most common type of relationship between different tables. It's something that you will use a lot, and it's good to know about it. So a one-to-many relationship kind of follows the same idea as a one-to-one, except in the secondary table, it can have many results that link back to the primary table, right? So think about it in the example of, so we used customer and profile in the first relationship example. Let's, in the second, so a one-to-many example would be, let me look at my notes, customer and orders. So think about this in the context of customers and orders. So if you're working for Amazon, right, and you're building their database, you're building their data model, you're going to have a table for customers and you're going to have a table for orders. Now think about it in the context of the relationship between the two. So a customer can have a lot of orders. There's not necessarily any limit to how many orders a customer can have. But on the other end, an order can only be associated with a single customer, right? So that's a one-to-many relationship. It's when the primary table is linked to potentially many entries in the secondary table. And the secondary table can only be linked to a single entry in the primary table. Okay. Any questions there? So type it into Slack real quick. How does the secondary table, how does the orders table link back to the customer table? How does it create that relationship? What's the word? Join. So join is how you would query that data, but how would it be created? Yep, Reed, James, Jordan, nice. Rain, nice. Created with foreign key. So that secondary table, which would be orders, right? That's going to have a column called, what would the column be called? Customer ID. Nice, Adam. So that orders table would have a column called customer ID, and the customer ID would be a foreign key that links back to the customer. What does the foreign key link to in the customers table? What's the column that it links to? ID, yep. So the customer ID column in the orders table is going to link to the primary key, which is the ID column in the customer table. That's a one-to-many relationship. Awesome. So you look like you guys are understanding this. Any questions so far, or have I lost you? Greg, we'll get to it. Patience. I know the theory can be boring, but it's good to understand. It's essential to understand. In fact, when you actually start job hunting, a lot of times companies will give you like a technical interview, and they'll ask you questions about theory, and you have to know it. It's not all just coding. Okay, let's move on to the last type of relationship. Many-to-many relationships. This one is fairly common as well. But this one is unique in the idea that when you create a many-to-many relationship, excuse me, when you create a many-to-many relationship, you need a third table to store the actual relationship, right? So think about this in terms of orders and products. All right, let's keep going with this idea of like working for Amazon. You're building Amazon's database. Amazon is going to have a database for their orders, right? It's going to be a huge database of every single customer's orders. And they're going to also have a database for every product that they sell on their website. Now, when you think about this, products can be associated with many orders, right? An order can have any number of products. And products can have any number of orders. So you can't use a one-to-many relationship here because obviously there's an infinite amount of connections that could be possible here. So it requires a third table. You would create a third table, something called like orders underscore products. And what's going to happen is that third table is going to store two foreign keys. So it's just going to have three columns. It's going to have an ID column, it's going to have an order ID column, and it's going to have a product ID column, right? And so that table kind of links together those two columns in any number of capacities. So you could essentially, if you want to link an order to a product, you create a new row in that table with the order that you want to link and the product that you want to link, and it creates that relationship. Does that make sense? So once you have that relationship in that third table, then you're able to query that data using joins. And you're able to say, for example, I want to get all of the products associated with this order. You would query the orders database and then join that third table, the orders underscore products. You join that in, and it would, return the results for you. Yeah, sure, Reed. Let's repeat that real quick. So when you create a many-to-many relationship, you're going to create a third table. Okay, so in this example, we have an orders table and a products table, right? Those are the two tables that we're working with. And an order can have any number of products. An order can be associated with any number of products, right? There's no limit to the amount of products that you can order. And at the same time, products can be associated with any number of orders. So it's kind of like on each side could have any number of associations. So you have to create a third table that holds those relationships, right? You can't just put like order ID. You can't put an order ID column in the products table. And on the other end, you can't put a product ID in the orders table, right? Because it has many. So if you think about it like in the terms of JavaScript, like if you're building a JavaScript object that holds like an object of orders, you could essentially just nest an array in that object with all of the products in that array, right? You can't do that in databases. In databases, you actually have to split up that relationship so that you're not storing an array in the database, but you're storing a relationship in a third table that holds that relationship. I understand this is confusing to talk about it, but we will see example soon enough. So if you don't understand it now, just hold tight and we'll be able to visualize it a little better soon. So Reed, when would you want to go in the direction of products to orders? Think about it in the example of say an Amazon executive wanted to go query the database and see how many times a product has been ordered, right? They would want to see the amount of times a product has been ordered, but if they didn't have that relationship, they wouldn't be able to query in that direction. Does that make a little more sense? NoSQL databases are a little bit different in terms of they don't really have relationships. That's one of the biggest drawbacks to NoSQL databases. We won't get into that tonight just because that's a deep, dark rabbit hole that can be really confusing. But for now, it's good enough to know that the NoSQL databases don't have relationships like SQL databases do. If you don't know what a NoSQL database is, don't worry about it. That's something that you'll probably learn later on. Mm-hmm. Yep, so it's just a way to link those two tables together. Yep, and you would use a third table. So you have an orders table and a products table. You would have a third table called orders underscore products that would hold that relationship. That's where you would create the relationship. And its sole purpose of that third table is to hold the relationship. I promise this will make more sense when we actually visualize it. Mind blown. That's why I do it. That's why backend is awesome. Okay, so let's think about some examples. So let's say we have a database that has a table for a profile. Let's think about Twitter, okay? So Twitter's database, they have a profile table that has all of their profiles in it, okay? And they also have a table for followers. So when someone follows you on Twitter, it creates a new row in the followers table, right? So what is the relationship between the profiles table and the followers table? Type in Slack. What is the relationship between the profile table and the followers table? Seeing a couple different answers. Everybody put in something. Want to make sure you understand this. Most of you are putting one-to-many. It is a one-to-many relationship. So if you think about it, a profile can have any number of followers, but when someone follows you, that specific follow can only be associated with one profile, right? When you click the follow button, you're not going to follow more than one person. You're going to follow one person. So it's a one-to-many relationship. Yep, one file, many followers. Good. So what about, let's say we have a table for a user. Let's think about it in the context of a government website, okay? For the TSA website, you are building a database that needs to store passport data. So you have one table for a person and for the info about a person, and you have one table for passport info. Now, what would be the relationship between the person table and the passport table? Type it into Slack. One to one. Good. Yep. Perfect. Because one person is only going to be associated with one row in the passport table. A person can only have one passport unless you have dual citizenship, but we're not going to think about that right now. John. Sorry, John. We're not considering you in this database. Okay, so what about right. Okay, so what about, let's think about a database for a grocery store. Okay, you're building a database for a grocery store. You have a table for, well, okay, not a grocery store, but a collection of grocery stores. Say you're building some kind of app for grocery stores and you need to store a collection of them and their suppliers, all right? So you have a database of stores and store names and, different grocery stores, and you have a table for different suppliers, the suppliers of their product. What would be the relationship between stores and suppliers? Type it into Slack. Many to many. Perfect. Yep. All right. So it looks like you guys are understanding the relationships. That's all you need to know, really, when it comes down to it. Boys to men. So those are the three different types of relationships you'll have: one-to-one relationships, one-to-many relationships, many-to-many relationships. One-to-many is not very common. One-to-one is not very common. One-to-many is the most common. Many-to-many is fairly common. So, any questions about relationships? Anything at all? Please feel free to ask any questions you have. If it's not clear, if you just don't understand it, let me know. Cool. Okay, so let me ask you a question. When you create a foreign key, so let's think about a one-to-many relationship. In the many side, you have a foreign key. What is the data type of that foreign key? What do you define the data type as? Ronnie, I'm not here to help with your actual relationship advice. I'm not qualified to give that type of advice. Int, yeah, well, kind of. So it's kind of an int. Anybody else want to give that a shot? What would your foreign key data type be? Dustin, yeah, hit it on the head. Your foreign key is going to be whatever the primary key is. Whatever the data type of the primary key is, the foreign key has to match. Okay. If your primary key doesn't necessarily have to be an integer. You could have instances where your primary key is a string. It's not recommended. It's not very common, but it could happen. And if that were the case, your foreign key would have to match the data type of the primary key. 99% of the time, your primary key is going to be an integer, or in some cases, like a UUID. And so your foreign key will almost always be an integer or a UUID. But it's important to know that the foreign key will have to match the data type of the primary key. Does the foreign key have to be unique? Yes or no? Do you think the foreign key has to be unique? Nope. There is one instance when it does have to be unique. When does the foreign key have to be unique? Yep. Perfect, Amy. The foreign key only has to be unique when it's in a one-to-one relationship. What about the primary key? Does the primary key always have to be unique? Yep, absolutely. Your entire system would break if your primary key was not unique. So primary keys always have to be unique. Foreign keys have to be unique some of the time. All right, so that's relationships. I feel like you guys have a pretty good grasp on that. If you don't worry about it, because we're going to be able to visualize it a little later. So just be patient. If you don't quite understand it yet, you'll be able to visualize it in a bit. So let's move on. In the training kit, we're going to talk about normalization. So normalization, data normalization is a very vague concept, and it's really difficult to understand at the beginning. I'll have to be honest, I don't quite understand it either. It's very confusing when you get down to it. But really, all you need to know is data normalization it's just terminology someone came up with to describe how well a data model is defined. You know, how organized and consistent your data model is built as, you know, whether you have any redundant data, whether you have relationships that shouldn't be there, relationships that should be there, or relationships that should be there but aren't, and relationships that are there that shouldn't be there, I should say. So normalization is just terminology that someone made up to describe how well your data model is defined. That's all you need to know. And I realize a lot of the stuff in the training kit is very confusing. It kind of goes into pretty detailed anomalies and all the different normal forms, and it's really confusing. So I don't want you guys to stress about this too much. We're just going to go through it really quickly, but don't stress about this if you don't quite understand it. If you don't quite understand the specific terminology, all you need to know is that, yeah, it's terminology someone came up with to define how, or to describe how well a data model is defined. So when it comes down to it, data models, when you're designing databases, they should be designed for maximum consistency and minimum redundancy, right? You want your data to be organized. You don't want any data to be repeated. You don't want like relationships to be there that shouldn't be there. It can result in a lot of disorganized data. It can result in a lot of inefficiencies in your queries, things like that. It can create these anomalies, these different types of anomalies, which I'm going to talk about here in a second. Yeah, Cam, it's very confusing, and I feel bad that it's even in there, but it's something that we need to know about, that we're just going to talk about it very quickly. So yeah, it really just comes down to how well your data is organized. So when you're creating your data models, you want to make sure that no data is repeated, that you have like different tables created for different types of data. So a table should really be self-contained, right? So a table should only describe one thing. So it's not usually a good idea to create a table that has like 20 columns for like all this different data. It's usually better to create different tables and kind of split that data up so everything is self-contained, and each table has a specific purpose, and then everything links together with relationships that we just talked about. So there's kind of different levels of normalization. But first, before we talk about the levels, let's just talk about the anomalies really quick and kind of what happens when your database is not normalized as it should be. So the first type of anomaly is an insert anomaly. So if you think about let's think about a database. Okay, well, first I'm going to explain what we're going to work on here in a minute. We're going to create a database for Lambda School. And that database is going to consist of all the different tracks and cohorts and students. And it's going to define all the relationships between them and everything like that. So if we say that Lambda School came to us as a client and said, build this database for us, And we said, okay, we're going to go ahead and design this data model. So we designed the data model without any normalization. We would essentially just create one table. We'd call it tracks, right? And tracks are associated with cohorts, right? A track can have many different cohorts. And so if your database was not normalized, you would essentially create your tracks table with the cohort data within that table, right? So your columns would be ID, and then you would have name, which would be the track name. Then you would have something crazy like if you look in this example, they're listing out farms and animals. They just have like these columns that are animal name 1, animal name 2, animal breed 1, animal breed 2. So in the example that we're talking about, like if you had the track database that was not normalized, you would have columns like cohort 1, cohort 2, cohort 3, and so on and so forth. And you can see that that's not a great idea, you know, because you're essentially limiting how your database is designed. You're limiting how many like cohorts can be associated with the track and so forth. And so that creates what's called an insert anomaly, because in that instance, you wouldn't be able to create a cohort. You shouldn't be able to create a track before you create a cohort, right? Creating a track is dependent on creating a cohort at the same time, because all of that data is intertwined within the same table. So that is what's called an insert anomaly, is when you can't insert data because it's dependent on something else. And that's the result of not having any normalization in your app, in your database. So if you look at this example here in the training kit, so when you get the first normal form, so there's 3 different normal forms. So this right here is an example of an unnormalized database. So you have the farms table, and then you have all of this animal data, and it's all just kind of in the same table. But when you enter the first normal form, you split it up. So you have the farm table and the animal table, and they're separate. And then the animal table links back to the farm table with a foreign key. So that first normal form, that's kind of the first step to organizing your data, to making it more accessible and more less repetition, and then just making it a lot better, easier to work with. The second type of anomaly is an update anomaly, and that's when your information is duplicated, and it's repeated across a lot of different rows when it shouldn't be repeated. This is pretty common with things like strings. So if you think about our example with students and cohorts, tracks and cohorts. So if a cohort had a column that was, say, let's see, what's something that a cohort would have? It would have a name, right? So you'd have like WebPT8. It would be associated with a track. And let's say it had, let's just for this example, let's say it had a location, right? So let's say a cohort. I know cohorts are not dependent on location, but let's say that they were. So if you designed your database, if you designed your data model in that second table with the cohorts table, if you put location data in that table, and let's say that you just listed out the city as a string in that, so you had a column in the cohorts table that was a string called location, and that's where you put the location of the cohort. Now let's say that you have several different cohorts in the same city. So you would be repeating that key, that city, you would be repeating that string over and over again if it wasn't organized correctly. And so that's where you would enter the second normal form. That would get rid of the update anomaly. I realize this is very confusing. I'm sorry. We just got to make it through this. Please ask any questions if you feel lost. So the second normal form is when all non-key data in the table has to fully relate to the key data in the table. So a good example with the Lambda School database is, let me just Look at, well, let's just use this example in the train kit. I realize we're kind of using two different examples here. So if you look at this example, let's just go with the farm and the farm animals. So when you enter this, you look at the first normal form. That's when we just split it up between farm and animal. Right? You use the foreign key to link the farm. And then if you look at the second normal form, you actually extract animal from farm animal, and you kind of have this third database with a many-to-many relationship to hold data about the farm animal, because you don't necessarily want the animal object to be associated with a farm. It's not always going to be associated with the farm, so you want that third table to create that relationship, and that's when you enter the second normal form. So I know this is confusing, but essentially when it comes down to it, it's just splitting up your data and organizing it more, using relationships more, utilizing like one-to-many relationships, utilizing many-to-many relationships. And it's just organizing things, making sure tables are single purpose. You don't want a table to have more than one purpose, to store more than one type of data. Okay. Questions so far? Any specific questions about the first normal form or the second normal form? One more thing to keep in mind is each normal form is dependent on the one before it. It's kind of sequential. So when a database enters the second normal form, it has to already be in the first normal form. So it kind of just sequentially goes through this process of entering each normal form until it's completely normalized and as normalized as it could possibly be. Mm-hmm. Yep, Wilfred. So that farm animal would be linking those two tables together. So essentially when you're normalizing, you're just kind of extracting columns into their own tables and linking them together with foreign keys to make things more organized. Mm-hmm. So that's when we get into the third normal form. And the third normal form is kind of like the last normal form. It's when your data is considered completely organized. And that's when columns in a table only relate to the primary key in that table. So you don't have any two columns that are related to each other that are not related to the overarching purpose of the table. And that's what's known as removing transitive dependencies. I know that's a confusing big word, transitive dependencies, but that's what it's called when two columns in a table, when all of the columns in a table only relate to the purpose of that table. Yeah. So when you remove those transitive dependencies, you are considered normalized. Your data model is normalized and you're good to go. So a good example, something that might help you wrap your head around the third normal form. So an example of when you wouldn't be considered in third normal form is, say you had a profile table that had a birthday column and an age column, right? So these are two columns that are related to each other, but they're in a table that's not, the overarching purpose of the table is not to determine the age of the person, right? So that's not considered in the third normal form because there's an opportunity there for a data anomaly, right? You could essentially have a birthday that doesn't match up with the age. And so it's good to take that data out of that primary database and put it in, or not primary database, sorry, I misspoke, primary table, and put it in its own table and link together with a foreign key. Christopher, yeah. It's pretty common for databases to not be normalized, to be really unorganized and crazy, and it creates a lot of problems. So that's why we're kind of learning about this, because once you understand this concept, you'll understand how to create a well-defined, a well-organized database. You know, when you're creating databases at your job, you're not going to actually be thinking about, oh, is this like first normal form? Is this second normal form? Like trying to figure out which step it's in. You're not even going to think about it. it's just going to kind of be second nature to know to model your database in the third normal form by default. When in the process do you start to normalize the database? From the very start. You should start at the very beginning. That's why you need to kind of practice this data modeling technique, because you should be building your databases from the get-go in the third normal form. You know, they should be normalized from the get-go. You should be constantly evaluating your data model to make sure you don't have any anomalies anymore, you know, to make sure everything is normalized, to make sure everything is organized, to make sure you don't have any repeating values anywhere. Because just like Christopher says, like a lot of big companies have unorganized databases, and it can eat up a lot of resources, you know, both like computational resources and like employee resources to build new features and things like that. So it's really important to make sure databases are organized and normalized. So those are all the different normal forms. I know that was confusing. Don't stress about it if you don't understand all of the terminology. It's really just comes down to it's almost like just comes down to CS theory. It's computer science theory. So don't worry about it too much. I don't think I've ever, over the course of my career, had to know like specifics about normalization. You know, just like I said, it's just kind of second nature to know, you know, how to organize a database and how to create a data model that's normalized by default. So the goal, Wilfred, is to achieve the third normal state. And it can be, there can be trade-offs to going, you know, that hardcore and to make it that organized, because it's a lot more work, right? It's easy to just create one table and just stuff everything into that single table and call it good. Like that's going to work. If you're just creating like an MVP, that's going to work, and you're going to push it up and it'll work fine. But then, you know, a couple years down the road, when you want to scale that, you know, say your company takes on funding and you need to build all these new features, you're going to have a big problem, because you have this terribly messy database that's filled with all this data, and you're going to have to clean it up, right? So it's definitely, there's trade-offs to doing it at the beginning, but it's always going to be worth it. You know, if you can kind of get to the point where you can create normalized databases that are in the third normal form by default, you know, that's kind of where you want to get. So you can, you know, just kind of think about that as second nature, and you don't even have to worry about, you know, which normal form you're in. Yeah, and it does result in a lot of one-off tables, but that being said, a lot of one-off tables is much better than having all of your data stuffed into one table. Even if you have to worry about more tables, you know, it's always going to be better. Messy databases are a nightmare to work with, so you never want to work with a messy database. Don't be the one responsible for creating a messy database. Wow, Greg, 500 column table, that's, yeah, whew. I would not want to work with that. Yeah, we will create one in SQLite, Justin, here in a bit. Just bear with me. We're going to actually get into the coding of creating a data model and actually seeing how it all works. So we'll get there. Good, Wilfred. Yes, it is helpful to know the basics before we actually get in to build stuff. Any other questions? Okay. So in the training kit, there's this example database. How would you normalize this database? Take a few minutes and look at this and tell me, type your answer into Slack, but don't submit it. Tell me how you would normalize this database. How would you get this to the third normal form? You are going to be the database engineer, Dustin. You have to solve this problem. How would you solve it? Everybody type in your answers. The more interaction we have here, the better. All right, Jordan, that's fine. We'll definitely be getting more into this in just a minute. I just want to see if you guys know the process of what would happen when we normalize this and kind of what we need to do. All right, so, yep. So, I mean, we could do a few things. I think in this example specifically, what we would do to normalize this data is we would create a second table for location. That second table is going to be city and state, right? It's going to have two columns, one for city, one for state. And it's going to have a primary key for each column. And in this users table, we're going to have a locations column, or a location column. And that location is going to be a foreign key that links back to the locations table. And yes, some of you are saying that we should split it up into a customers table, a state table, and a city table. You know, I mean, you could definitely do that, and that wouldn't be a problem. You know, that would be considered in the third normal state. In this case, since the city and the state are related, you know, they're two items that are related to each other, it makes sense to put them in one table. But either way, is not, I mean, splitting the state and the city up into separate tables, that's not wrong. So really just comes down to how organized you want your data to be. As long as each table is self-contained with the type of data that's in it. So if we were to create two tables here, the locations table would have the city and the state. Those are both related to the location. So that's okay that they're in the same table. Yep, it could go from one to many. That's true, Greg. New York represent. Is anybody else here from New York? Long Island, nice. Boston, Central New York, nice. Buffalo, Bushwick. Oh, sweet. So you're in the city, Christopher. Nice. I'm just over in Manhattan on the Upper West Side. All right, so let's take a quick break. I know this is a lot to digest. So let's take a 5-minute break and we'll come back. Okay, we're back. See if I got any questions. You like that timer? It's built in Python. You think it was going faster? 1.5 speed, really? I don't think so. I would trust the computer clock. Upper West Side better than Upper East Side, Chris. I agree. I love the Upper West Side. Bushwick is cool too. I lived in Brooklyn for a while. Okay, so I'm going to create a poll real quick. I just want to understand how well you guys are understanding this. It's going to be anonymous. Let's see here. All right, go ahead and answer that poll just so I can get a feeling for where everyone's at. Okay, so it's kind of all over the place. Wow. For those of you that are answering 1, 2, 3, I promise it'll make more sense when we get into it. We're going to get into it right now. We're going to get in and actually build the data model. We're going to draw it out, and then we're going to build it with Next. So it'll make more sense when we do that, I promise. And if it doesn't, then please feel free to ask questions, and we'll help you understand. Yeah, SQL is, I mean, it gets pretty confusing, but it's a very marketable skill. You go to a company, say you know SQL really well, you'll make the big bucks. Yeah, I mean, SQL is used even outside of development. Like, I think a lot of like data science, well, yeah, data science is kind of development, but data science uses a lot of SQL. Even like, I think like accounting uses a lot of SQL as well. It's really just a really good tool for querying data and storing data. Yeah, people with MBAs, that probably does a lot of SQL for sure. All right, so let's go ahead and draw out a data model. So if you have access, I'm going to do this on my iPad, but if you have access to like an iPad or maybe even just pen and paper so that you can follow along, now would be a good time to go grab some pen and paper and we can draw this thing out. No, Rain, you cannot do that. You cannot outsource your job unless you own the company. If you own the company, absolutely. If you don't own a pen and paper, that's all right. You can just follow. You can just watch me. Yeah, that's fine. Or if you have, like, you can even do it like in a Google Sheet. Yeah, there's a lot of different options. We're just going to be drawing out basically some tables. So whatever works, whatever's most comfortable for you. On your forehead. Back of your hand. That's how real developers do it, right? We just write stuff on all over our body. All right, can you guys see my iPad screen? All right, perfect. Okay, so let's say, we're gonna go with this example of the Lambda School database. Let's say Lambda School came to us as a client. Say we're freelancing and Lambda School comes to us and they say, I need this database for our company. You know, we need to store all of our different tracks, all of our different cohorts. We need to keep track of our students, and we need to keep track of all the relationships between them. Okay, so what would be the first thing we draw out? What's going to be the first table that we need? We're going to need a student table. Yep. What else? Cohort table. And one more. Tracks. Yep. So let's create a tracks table. That's going to be the main table that we're going to use in our relationships, right? We're going to have a cohorts table. Perfect. And then we're going to have a students table. So something you'll find when you're creating data models, some of the best ways to create data models is just like, you know, writing it down on a piece of paper or whiteboarding it if you're working with other people and you're whiteboarding. Just writing it out, you know, with an actual on a physical medium is really helpful, because then you can move things around. You know, you can do stuff like that, and it's really helpful. That's nice. Where'd that come from? That's weird. I guess that's Zoom's whiteboard feature. I've never seen that before. Let's see if I can clear that. Yeah, please don't write on the whiteboard. That's distracting. I think I can disable that somehow, but I'm not quite sure how to do that. Tyler, if you know how to disable that, that would be awesome. Okay, so we have 3 different tables here. We have tracks, cohorts, and students. What's going to be the columns for each one of these? Let's start with tracks. What are going to be the columns that we need in tracks? Type of amount. What do we need for tracks? We need name. Yep. ID. Yep. Let's just keep it simple. Let's just do ID and name. Perfect. So we got ID and name. What are going to be the data types for those 2 columns? What's the data type for ID first? Int. Yep. It's going to be an int. In SQLite, we're going to mark it as auto-incrementing. So whenever we enter, or whenever we insert a row, it's going to auto-increment the integer automatically. What kind of key is going to be on ID? Primary. Yep, Justin said it right there. Primary key. So we're going to just say. What about name? What data type is name? String. Yep. Varchar. So in SQL land, a string is most commonly known as a varchar. So it's good to remember that. So we're just going to say varchar. And it's also important to remember when you define a varchar, you have to give it a length. So you have to give it a maximum length that string can be. So we're just going to say 128, because that's kind of the common length to use for strings. Okay. What about cohorts? What does cohorts need in terms of columns? Just the same stuff, right? Let's just give it an ID and a name. Data types are going to be the exact same. It's going to be an int, primary key, a varchar. And then let's also just give the same to our students, right? Let's just keep it simple for this example. So the students are going to have an ID and a name as well. Yeah, Jasmine, are you not seeing any writing? Oh, shoot. Let me. I swear I tested this and it worked. Let's try this again. Can you see this? Awesome. Perfect. All right. Okay, so I'm just basically writing out our data model here. So we have each table, and we have each column under the table. We're just kind of organizing our data here. We're mapping it out to see how it's going to intertwine with each other, how it's the type of relationships we're going to need between them. Planning out the data types, planning out the columns, the column names, basically everything that our data model is going to need. We're planning out for it right here. Okay. So let's think about the relationships. What's the relationships between these tables? To start out, what's the relationship between tracks and cohorts? Cohort ID, yep. What's the relationship though? One to many. Yep, Rain got it. So the relationship is one to many because tracks can have many cohorts, right? But a cohort can only be associated with one track. So we're going to need to associate that cohorts table with the tracks table with cohort ID. So a couple of you put that in there, Justin, Greg, nice job. So we're going to call that column cohort ID. I mean, not cohort ID, I'm sorry. We're going to call it track ID because we want the cohorts to associate with the tracks, right? The cohorts are the many side of the relationship and the tracks are the one side of the relationship. All right, so we're going to call that track ID. Yep, you would specify non-nullable. I don't know if you would specify unique in this case because multiple cohorts can be associated with the same track. So you wouldn't want that foreign key to be unique. That makes sense. Okay. So track ID, what is the data type of track ID? It's an int, right? Why is it an int? Why is the track ID, why does it have to be an int? Yep, exactly. Because it's going to be a foreign key, right? We're going to define that as a foreign key, and foreign keys have to match the same data as the memory key. Yep, ID is a number 99% of the time. And since our cohorts table is linking to the tracks table, so we're linking to that ID of tracks. ID of tracks is an int, right? So track ID is going to have to be an int as well because it's linking to that ID. Perfect. So that defines our relationship between tracks and cohorts. That's a one-to-many relationship. What about the relationship between cohorts and students? Seeing a couple different answers here. Seeing one to many, many to many, one to many, one to many. It's going to be a one-to-many relationship. Okay, one cohort is associated with many students. Students can only be associated with a single cohort. Not yet, Christopher. We're going to get to that. But for now, let's say that students can only be associated with one cohort, all right? So we're going to create that relationship in our students table. We're going to call that cohort ID. And again, that's going to match up with the data type of the cohort's ID column. So it's going to be an int, and it's going to be a foreign key. All right, so now we've defined our relationships between these tables, a one-to-one relationship or a one-to-many relationship from tracks to cohorts, and a one-to-many relationship from cohorts to students. So that's a data model, like in its very simplest form, that's a data model. You know, we can kind of draw out our relationships a little bit here, draw out our tables. You know, so tracks is going to be linked to cohorts, cohorts is going to be linked to students. So when you're drawing out a data model, what you want to do for relationships is you want to write out the relationship. So the way that you write it out when you're doing a data model is you say one to star. So that's symbolic of one to many, right? And here it's going to be one. Yeah, here it's going to be one to many as well. So those are both one to many relationships. That's a basic data model. That's what this lesson was all about, is organizing our data in a way that is reusable and organized. Okay, so let's take this a step further. Let's say Lambda comes back to us and they say, oh, you know what? Students can now be in multiple cohorts at the same time. Students are no longer associated with just a single cohort. They can be in multiple cohorts at the same time. So now our data model doesn't work. So what do we need to do now? Type it into Slack. What do we need to do to make it so students can be associated with more than one cohort? Yep, we're going to create a new table. Why are we creating a new table? That's one approach, Dustin. Freak out? Quit? No, we're going to solve it. So we have to create a new table to model the many-to-many relationship. That's exactly right. What should we call our new table? Yep, let's call it cohorts _ students. The order doesn't necessarily matter, but we're going to call it cohorts _ students. Or students _ cohorts. Really doesn't matter. Are you not seeing the updates on the iPad again? I don't know why it keeps doing that. Oh, it's good now. Okay. It's probably just laggy. Yeah, please let me know if it cuts out. Time to upgrade to Linux. I know. Apple has really been disappointing me lately. It's a shame. It makes me sad. I do love the new iPads, though. I mean, they're pretty incredible. They do have issues, but when you think about it, they're pretty incredible. Trust issues, yeah. Oh, weird. I don't know what that pop-up was. I haven't had issues with this in the past. I don't know why it's being weird. Okay, so we have the cohort students table. What are the columns that we need? What are the properties? We need an ID, definitely. Every table needs a primary key. Every table needs an ID. What else? Cohort ID and student ID. Yep, remember this is a relationship table. This is defining a many-to-many relationship. The sole purpose of this table is to define the relationship. So we need an ID for the two things that it's connecting, the two ends of the relationship, right? So we're going to need a cohort ID, and we're going to need a student ID. What are going to be the data types of those two columns? Int, yep. And it as the original primary keys of cohorts and students are both ints. They're both going to be int, and they're both going to be foreign keys. Ugh, my handwriting is terrible tonight. I apologize. Any questions so far? Yeah, John, when you migrate the database schema, it would just be a matter of creating the new table and creating the relationships based on the old data, right? So it's just a matter of structuring your migrations in a way that can change the database structure without losing data. So it can be tricky, to create that migration, but it is possible. Since the ID isn't really used, could the primary key be a combination of the cohort ID, student ID, which would also be unique? Yeah, I mean, the primary key just needs to be unique. I guess the combination of the cohort ID and the student ID isn't necessarily unique, because there could be instances when there's more than one relationship of the same sides. It's probably pretty rare, so don't concern yourself over that. But I wouldn't trust a combination of those two IDs to be unique all the time. Whereas a primary key with just an ID on the relationship table is guaranteed to always be unique. It's pretty important to just have a primary key that is unique on every single table. That's just kind of the way to play it safe. Jordan, when I write FK, I'm just meaning foreign key. FK means foreign key, and PK means primary key. So that's our fourth table. And now what we can do is we can get rid of this relationship between the students and cohorts. So we no longer need this relationship. We no longer need cohort ID. But we have a new relationship now between these two tables. It's going to be a many-to-many relationship. That makes sense. Any questions? Yeah, John, I guess students could be a member of multiple tracks. We're not going to worry about that. But yeah, I mean, essentially, you just have to create another table to house that relationship, to house the many-to-many relationship. All right, so now that we have our data model, let's take another 5-minute break and then come back and code it in Next using migrations. So take another break, and I'll see you in 5 minutes. Okay. No, I don't think that timer is fast. It seems to be. We started at, yeah, okay. No, that seems legit. Give everyone a few minutes to come on back here and we'll get started. Nice diagram, Greg. Yeah, draw.io works very well for that sort of thing. Looks good. John, let's take a look at your question here. If we did create the many-to-many relationship, yeah, that's getting pretty into the weeds. I like that you're thinking about this, though. You know, you're kind of thinking about the data from a higher perspective. And to answer your question, you wouldn't link the tracks and the students, because the tracks and their students are linked together through the cohorts, right? You don't want to introduce another relationship. You want the students to always be associated with the cohort and cohorts to always be associated with the track, right? So if you wanted to associate a student with another track, they would be associated with the cohort that's associated with that track. You wouldn't go the other way around. So it's good that you're kind of thinking about this, because it lets you, work out those issues before you actually create the database. Okay, I'm going to upload our data model to Slack so that you have it as a reference. Yeah, Christopher, just like I said, the data model we have does cover students being enrolled in multiple tracks, because tracks are always going to be associated with the cohort, and students can be associated with multiple cohorts now, which means they can be associated with multiple tracks. They just have to be in the correct cohort. Okay, and we're gonna work off of the guided project that's in TrainKit. I'll post a link to that as well. If you want to go clone that, we're going to be working directly from that repo. If you want to follow along, please do. So go ahead and clone that down, open it in your code editor. So it kind of gives us a boilerplate to work with here. We've got a package.json. We've got a few packages installed. We've got Next, Express, SQLite, everything we need to get started. So let's get started. So now that we have our data model, what's the first thing we need to do? If we want to start building this in code, what's the first thing we need to do? Or the first command we need to run? Yep, npm install, perfect. Npm install, or if you have yarn, you can just type yarn. Either or, doesn't matter. It'll install dependencies for us. What's the next thing we need to do? Not next init, Greg, because if you look at our repository, we already have a next file. So we already have that set up. We don't need to init next. But what's the next thing we need to do? You got it, Rain. We got to make our migration. So we're going to create our first migration. So let's say npx, or if you have yarn, you can use yarn, but let's use npx and say next, migrate, make. Let's call it initial. Creates our migration for us. So now we have our migration file. We can just clean up a little bit. Next gives us some defaults to work with. Actually don't need this promise parameter. I usually delete that just to, because I don't like looking at it because I don't need it. But from there we can start creating our actual migrations. So do you remember how to create a table? What's the code I need to create an actual table in my migration file? Let's say the first table we're going to create is our tracks table. Type the code that you would use into Slack to create our tracks table with Next. Perfect. John, Ronnie, Jonathan, nice. So we're going to say next.schema.create table. One difference though from what you typed is we need to give it the table name. So we're going to say tracks, and then that gives us a callback with the table object. Just like that. Good catch, Greg. We do need to return. This function needs us to return a promise. So we could do return like that, but I'm going to do something a little bit different because we're going to create multiple tables in this migration file. So I'm going to turn it into an async await function, which is the same thing as returning a promise. Like that. Good. So now let's start creating our columns. Good, John. Table increments. That's going to create our ID. Let's be specific with this and say we're going to call that column ID. What's the next column? Next column is going to be name. So we're going to say table.string, because JavaScript doesn't know about varchar. JavaScript only knows about strings. But what Next does is it converts that string into the correct data type for the database. So we can just say string. We're going to call it name. And in this case, we're going to want to say unique, because we don't want multiple tracks with the same name. That would not be good. We're going to say not nullable. Ronnie, if you use dot increments, it's assumed to be primary and assumed to be unique. Yep, exactly. Table.increments is basically a shortcut to saying that. We love shortcuts in the programming world. Use them. All right. Rain, let's not do timestamps. That just complicates it. For now, let's just keep it to match our data model. So just ID and name. Okay. Next table, we're going to create cohorts. So we're going to copy that, say await next.schema, create table cohorts. And that has the exact same stuff as tracks, the exception of the relationship. So do you know how to create a relationship in Next? Have you done that yet? It's pretty straightforward. See, Dustin and John are typing. I don't know if you know what the command is. If you do, great. I'll give you a second. Nice, Dustin, yep. That's the second half. What's the first half? We're going to say table.integer, right? Because we need the same data type as the original one. We're going to call it tracks ID, or track ID, I should say. Going to reference tracks. I mean, reference is ID, not tracks, my mistake. In table tracks. All right? We want that to be not nullable. Yeah, Christopher, it's really up to you. You can always put different tables in different migration files if you feel like it makes you more organized. It's definitely not a requirement, especially in this case since our tables are so small. You can do it all in one. It's totally fine. Yeah, Wilfred, you copy and pasted that from the training kit, correct? That has a lot of stuff in it that we're not going to worry about. The dot unsigned. I mean, that's useful, but it's not necessary in this example. We don't worry about it. And the on delete. Let's do the on delete. That's good. This up a little bit. So who knows what it means when we say on delete cascade? Do you know what that means? We are promised to be informed of what that means. Okay. I will tell you what it means. So database cascading is very simple. All it means is when the referenced row gets deleted from the tracks table, you want that transaction to cascade down and delete the cohorts row that's associated with it, right? Because if you delete a track, say if you delete the full stack web dev track, say they hire everybody and no one wants to learn anymore and they delete the web dev track, you want all of the cohorts to be associated with that web dev track to be deleted as well, because otherwise you'll just have cohorts floating around that aren't associated with the track. Otherwise it's a big mess, yeah. Exactly. On update, yeah, you would also do that. In this case, we're not going to do it because there's nothing that we're really updating. All that would do is it would update like the ID, if you updated the ID of the track, which you should never do because it's the primary key. But yeah, like if you were linking something else other than the primary ID, you'd want the on update as well. Yep. There's several options that you can put here. Cascade is not the only one. You can also do like set null, which will set that column to null when the parent gets deleted. I think there's one that's like restrict, which would disallow the tracks from being deleted when it has referenced cohorts, which is useful in some cases. In this case, we're just going to do cascade. That makes sense. All right, next table, we're going to do students. Students is going to have the same stuff as the last table, so I'm just going to copy and paste it. An ID and a name. Now we need to create the fourth table, which is our many-to-many relationship. So we're going to call this cohorts underscore students. This is going to have an incrementing ID, just like all the other tables. And then we're going to have two reference columns, right? We're going to have a cohort ID. Cohort ID is going to reference ID in the table cohorts. And we're going to just copy this stuff from our cohorts table so that we don't have to retype it. And then we're going to do that exact same thing, but with student ID. You're just going to rename this to student ID. It's going to reference students. Okay, so that creates our references. I'm actually, in this case, I'm going to put these all on the same line just so that you can see more at once. Make it a little bit easier for you. Right now you're able to see all of the migrations at once if you're following along. Yeah, absolutely, Christopher. I will give you these files when we're through. You bet. Any questions so far? You guys keeping along? All right, what about our down function? What do we need to do here? What do you think? Yep, you guys got it. You got to drop the table because remember the down function should always reverse whatever happens in the up function. It should always be the reverse. So if you create a table in the up function, you got to destroy it in the down function. Yeah, there is rain, but you definitely do not want to do that because what if you had a previous migration that created a table that was not in this one? You would accidentally delete it outside of this migration. You never want to alter anything outside of the migration file. So down you got it, except you missed one. You need the cohort students table. So what we need to do is we need to delete these databases in the reverse order that they were created in. Because if we try and delete tracks first, we're going to have rows that references track, and if we try and delete students before we delete this table, depending on the database engine, it'll yell at us because we have foreign keys that are pointing to that table and it's not going to let us delete it. So in this case, we're going to say next drop table if exists, and we're going to do this cohort students table first. And we're going to need to make this an async function as well. And then just the last three tables. So we're going to delete students, delete cohorts, and lastly, we're going to delete tracks. And that reverses everything we did in our migration file. So that's all we need. That creates our database model. Everything that we drew out in that data model, we now have created in here. The drop function, it deletes the table and recreates it. Well, no, it doesn't recreate it. I'm sorry. It just drops the table. The reason why we say if exists is because SQL will yell at us if we try and delete a table that doesn't exist. So what that function does is it checks to make sure the table exists. And if it does, it drops it. If it doesn't exist, it just doesn't do anything. So drop is SQL syntax for delete, basically, deleting table. Not yet, John. We're going to get to seeds in a minute. Let's try and run our migration first to make sure it actually creates our database. So I'm going to say npx next migrate latest. Unable to open a database file. Oh, we have to create the data folder. That's why. So let's create a folder called data. Try and run that again. Boom, batch one run. Batch one run, one migrations. I don't know why it words it like that. That's weird. But it created our lambda.db3. So this is our SQLite database that has been created for us. Let's go into our database browser and see if it created that structure. So I'm using DB browser for SQLite. You can use SQLite Studio, which I believe is what was in the training kit. Whatever works for you. If you're on Linux, you can use whatever works best on Linux, as long as it allows you to browse the database and run SQL queries. So I'm going to go ahead and open that database file. And look at that. We got our database. Created our tables for us. If you look in here, it created all of our references, all of our foreign keys. Ready to go. Wilfred, you can if you would like. You can definitely put them wherever you want, as long as you just want to make sure that the migrations folder and the seeds folder are committed to your GitHub repo or your repository, wherever it's hosted. In that case, you can, in your next file, you can define the location. So you can say like migrations directory, and you would say data/migration. And the same for seeds. If it helps you be a little bit more organized, by all means. Greg, do you need unsigned in cohorts? I guess it's not hurting anything to be there. that's just the difference between assigned and an unsigned int. Basically, assigned int can go into a negative value, and an unsigned int cannot go into a negative value. And the max limit for an assigned int is like some crazy high number. I don't remember what the exact number in JavaScript is, or in SQLite is, but we would probably never reach it for this example unless we had like millions of cohorts. So you can put it in there if you want, but you don't have to. Yeah, VC always included that. I mean, if this was a real production database and we were actually like building something that was going to be used in production, it would be important to go through every column and make sure you have, you know, every not nullable, every unique, every, you know, unsigned, signed, whatever it needs. But in this case, we are running short on time, so I'm just trying to keep it simple and straightforward. So you can definitely feel free to go through the next documentation and, you know, try and figure stuff out, you know, figure out what's available. If you just go into your browser, .org. Yeah, migrations ran. If we go into our table, the next migrations table, and we browse audio got interrupted. Is it still laggy? No, my roommate's probably watching a video. That's probably why it's getting laggy. Give me a yes or no. Can you still hear me okay? Oh, good. Okay. Dustin, no. Everyone else okay. Dustin, I'll come back to you soon enough. Don't worry. All right. So if you look into your database, you look into the Next migrations table. This is a table that's specifically created with Next to keep track of our migrations. So you can see that it has that migration file that we created, and it assigned it to a batch number. You know, so that's where it kind of keeps track of our migrations. So if we go into our project again and we want to roll back those changes, we say npx next migrate rollback. And when we run that, what it's going to do is it's going to go into that next migrations table, and it's going to roll back the last batch. So it's going to look at this file and say, oh, that's the file that we need to roll back. Let's go into that file and run the down function, right? So if we run that rollback, it's going to roll back that last batch. So now if we go into our database, you can see it deleted everything except for the next migrations table. So that's useful when you're testing. If you're just changing your data model and you're constantly like recreating your database, it's useful to, you know, roll back the changes and apply them, you know, back and forth as you're changing stuff. But you never want to roll back a production database unless, you know, there's some issue that made it crash or something that's really serious that you need to roll back. And that's an instance when you would actually go into production and roll back. You know, you want to have that function available in case you need it. But you never want to use it in production unless absolutely necessary. So let's go ahead and run our migration again so we get our our schema back. Cool. All right, so let's go ahead and add some seed data. So, well, before we get into that, any questions with migrations? I know some of you are still a little unclear on or you were a little unclear on migrations. I hope that clears it up for you to actually see a working example of how we would code migrations from a data model. Give me a yes or no. Does that make sense to you? Are you understanding it better? Awesome. That's what I like to hear. Sweet. Gotta love the memes. All right, so let's create some seeds, some seed data. So I'm going to say npm npx next seed make. Let's create one for tracks. So we're going to say 001 tracks. You got it, John. It creates this file for us. It gives us some boilerplate. We don't need it, so let's get rid of it. And we don't need this promise parameter. We can get rid of that. And we're going to need it to be an async function because it's expecting a promise. Now we can start writing our seed data. So we have that next object. We're going to say next. Next is a function that we can call. We can give it a table name, tracks, insert. So we can insert an array of data. So now let's just give it some dummy data. So we can say ID1, name, CS. We can give it an ID2, the name of full stack web dev. Let's give it one more. Say iOS, an ID of 3. All right, so that should give us some seed data. Should we run it? Do we need the ID since it has a primary key? No, you can leave the ID out and just let SQLite do its auto incrementing. I like to define it in my seed data because a lot of times when you're putting in seed data for the relationships, you have to put in the ID for that relationship, right? And so it's good to be explicit with what ID you're working with. So I like to specify it specifically in the seed data. You don't have to by any means, but it's a good idea. So we have that first seed. Let's see if it runs. Let's just say npm next seed run. I ran it, ran one seed file. So let's browse our data, go into tracks. There it is, it created our seed data for us. Awesome. Any questions so far? So you can see the usefulness of seeding of seed data, because say that we're using seed data to test our database. Say we're running automated tests against our database and it's changing values, right? What if we change this iOS to Android and apply it? Right? So now our database says Android instead of iOS. If we want to get that back to our original seed data, we would just run the seed again, right? What do you think is going to happen if I run this? You think it's going to overwrite the current data? Let's try it, shall we? No. We got a nasty error. So the reason we're getting this error is because we haven't cleaned it yet, right? It's trying to insert data without deleting this data first. So it's trying to insert something with a primary key of 1, but primary key with 1 already exists, so we're getting this error. So yeah, Adam, we need to create the cleaner. So let's create a new seed file. Let's call it. It needs to run before tracks, you know, because remember the seed files need to run in order. So let's call it 000. Call it clean. So now we have this clean file. The same as the other seed file. We can await next. Actually, no, we're not going to use next in this one. What we're going to do, we need to import the cleaner, because if you look at our package.json, you already have a dependency that's installed. It's called next cleaner. What next cleaner does is it empties your database for you, so you don't have to manually go drop every table You don't have to manually go delete every row and go through all that trouble. Next Cleaner will do it for you. So we can import it. Let's say cleaner equals require next cleaner. Now we just run it. So we're going to say await cleaner.clean and pass it the next object so it knows how to connect to the database. And that's it. So if we run that, since the seed files are going to run in order, next is going to come through and it's going to run clean first. It's going to empty the database and it's going to repopulate our tracks seed data. So remember, we changed that value to Android. So our database currently says Android. Let's go run our seed data. So run next seed run. No, we got another error. What do we have here? Seed delete from next migrations. Database is locked. Oh yeah, right. You're right, Ronnie. I forgot about that. So the training kit does have a little error. We need to pass an object to next cleaner, and we need to specify that we don't want to destroy the next migrations tables, right? Because those are tables that are not associated with our seed data. They're associated with the migrations, so we want to leave them alone. Now, I don't remember the exact syntax, so let's just go look it up. Just Google next cleaner. Let's go look at the package on GitHub. Oh, you have it right there, Cassia. Perfect. Thank you. So let's say mode delete. We want to ignore tables. We're going to ignore next migrations and next migrations lock. Perfect. Let's go ahead and run that again. And oh, another issue. So the database is locked for some reason. Not sure why it would be locked. Any ideas? See if we can debug this. Maybe DB browser is locking it. Yeah, that was it. My database browser was locking the file because it was trying to make changes. Let's reopen that. Okay, so we have iOS. Let's change that to Android. And that's going to lock it again. So now we need to write changes. And when we write the changes, okay, that's what we missed. So once we write the changes, then that lock is no longer in place. So now track number 3 says Android. Let's try and run our seed data again. Boom, ran 2 seed files. So it should have cleaned it out and repopulated it with the seed data. There we go. We got iOS there back. iOS is better than Android. Convince me otherwise. All right. So that is a simple way to seed our database. Since we're pretty much out of time, I'm not going to go through and do the seed data for all of the other tables, but essentially all you would do is come in here and create new seed files with next. You just say next seed make. You'd say maybe 002 cohorts, right? And then you do the same thing with cohorts and the same thing with students. And then you do the same thing for the relationship table. In fact, yeah, we're running a little late on time, but I do want to show you how to seed a relationship real quick. So let's create a cohort that's assigned to a track. So real quick, stay with me here. We're going to create a cohort. We're going to give it an ID of 1 because that's the primary key of the table. It's the first item in the table. Name, we're going to say WebPT4. We're going to say track ID. Now, what is track ID going to be? If you look at tracks, what should we make a track ID? No, Rain, that's actually a good point. It doesn't know where to start incrementing. And if this was a full-on app, if we were actually working on something big, you would want to, when you're seeding your data, set the increment level or set the increment number, which you can do through Next. I don't remember the command, but yeah, you can set that increment number automatically. So what do you think the track ID should be for the cohort? Should be the ID of our full stack web dev track, right? So you see we have ID 2 here. We're going to set that as the track ID here. That's going to create our relationship for us. So let's try and run our seed again. And it ran it. So now if we go into our table, we see our tracks are there. We go to cohorts. You see we now have WebPT4. Track ID is set to 2. And since that has a foreign key, you see if I hover over it in DB browser, it gives us a little popover that says it references tracks ID. Hold Command Shift click to jump there. So if I hold Command Shift click, you can see it brings me to the track that it's associated with. So you see it set up the foreign keys for us, did everything it needs to do. Cool. That's it. We've now created our data model. We wrote it all out. We planned everything. We made sure it was normalized, and we coded it. We created the data migrations and the seeds data. Congratulations, you've now made it through the data modeling sprint. Time for the sprint challenge. You guys are going to kill it. I know it. Any last questions before we end? Anything that's unclear? Anything that's bothering you? Absolutely, Justin. I will be your Miyagi. It would be my honor. Dustin, my day was great. Thank you. Thank you for asking. How do you see that it was referencing again? So it depends on your UI that you're using. If you're using SQLite Studio, it might be a little bit different. In the DB browser, if you go into, you hover over the row that has the foreign key, it'll tell you what it references, and it says hold Command Shift to jump there. That's just a shortcut in this program, and it'll bring you to that foreign key where it points to. Did you need the code you added mode since DB browser was the reason for the error? Yeah, we probably, what would have happened if we didn't put this in? Since DB browser was the error, it would have ran even if we didn't have this. But we do want this at the same time because we don't want our seed data to clear out our migrations. We want those migrations to stay put. Let me show you I'll show you real quick what happens if we take it out. Let's take that out. And then if you look in our database right now, you see we have it in place, that migration. It's keeping track of our migrations for us. If we seed that data without those options, it's going to clear out our migration data. And we definitely don't want that to happen. We want to make sure our migration data stays put, which is why you need this. Okay. Well, thank you for sticking with it. Sorry we went a little over on time, but hopefully you understand migrations a little bit better and seeding a little bit better. Please feel free to ask in the channel or reach out to me directly or the project manager directly if you have any specific questions. And good luck on your sprint challenge this weekend. You guys will do awesome. And next week, we're going to be talking about authentication. So I will see you guys next week.